Hello, everyone. We're just going to wait another minute while we let the last of the participants join us. So please bear with us just for another minute. Thank you. Hello, everyone, and welcome back to our regular monthly online research seminar. For those of you that are first timers, my name's David Lamb. I'm the Chief Scientist of Food Agility Cooperative Research Centre, and I'll be your MC. I'm based in Armidale, which is located in the New England Tablelands region of northern New South Wales. I'd like to acknowledge that I'm speaking to you today from the country of the Anaiwan people. I'd like to pay my respect to the elders, both past and present, acknowledging them as the traditional custodians of knowledge for this land. So welcome. For those of you unfamiliar with Food Agility, we're a CRC dedicated to unlocking the power of digital to transform our agri-food sector. For us, it's about research empowering business. The aim of our monthly seminar series is to bring to life some of the amazing projects and people in our research community. Today, you'll be hearing about one of the 15 projects we as a CRC have presently in delivery. Now, before I introduce our speakers, just a little bit of housekeeping as a reminder. First of all, this session is being recorded, and ultimately we'll make available a recording to you, to all registered participants. So if you have colleagues that aren't here, please ensure they register even now so that we make sure we can get the link sent out to them at the end of the proceedings. We welcome questions throughout. However, use the Q&A tab located at the bottom of your screen. Don't use a chat tab. If you use a Q&A tab, then we'll be able to pick those questions up. It's not possible for you to ask those questions direct yourself, but at the end of the presentation, I'll work through them live and retail them to the presenters in an interview style. If there are too many questions to cover in the Q&A session at the end, I'll pick a couple of representative ones to ask. And of course, if you have a burning desire to follow up on anything that you've heard in today's presentations, then please follow up directly with the presenters. Now, today's presentation is timely and topical. Christmas is coming fast. So let's talk seafood. The Sydney fish market is the largest of its kind in the Southern Hemisphere and is the world's second largest fish market in terms of variety, the largest, of course, being in Japan. Annually, the Sydney fish markets trade more than 15,000 tonnes of seafood. Now, back in 2001, the markets launched an innovative new online-based seafood trading system called SFM Live that operates in addition to the Dutch auction system. Now, a note on the Dutch auction, if you've never been to one, it's worth going. Imagine bidding for a product starting at the highest price and working down to hit the bid target. And the first one that blinks, of course, wins. So it's something to behold. SFM Live provides traders and advanced facilities for direct online seafood sales, including wild harvest, aquaculture, and frozen products, taking fish trading to a whole new level. Today, we're going to hear from our team that's going to take that trading to an even higher level. The topic of today's research presentation is around a fish provenance and tracking system developed in partnership between University of Technology Sydney, UTS, Sydney Fish Markets and Food Agility CRC. And it's a winner too. This project scooped the New South Wales Eye Awards for 2020 in the category of Business and Industry Solution of the Year. So congratulations to the team on that. Now we're going to be hearing from 6 presenters today, and I'll just list them in order. Peter Lonergan, who will open the proceedings, is a business research engagement manager from UTS, who will provide some background comments on the project and the partnership. Professor Ren Ping Lu is a project leader and heads a discipline of network and cybersecurity at UTS. Ren's interests include 5G, VNet, IoT, cybersecurity and blockchain. We'll also be hearing from Associate Professor Stephen Schoof from the School of Biomedical Engineering at UTS. Stephen's research interests includes data acquisition and distribution systems, system control and identification, signal processing, as well as biomedical instrumentation, system modeling and control. Dr. Ying He is also presenting, and Ying comes from the School of Electrical and Data Engineering. Ying's research interests includes low-power IoT devices and firmware design. We'll also be hearing from Associate Professor Zhan Zhang from the Faculty of Engineering and IT at UTS. Zhan's research interests include, among many other things, advanced image processing, another feature of today's presentation. And finally, Dr. Xu Wan, also from the School of Electrical and Data Engineering at UTS. Xu's research interests include telecommunications and blockchain inventory management. So we have a stellar cast of presenters from highly technical and diverse backgrounds. So it's with great pleasure that I introduce Peter, Ren and the team to tell us about their award-winning blockchain-enabled fish provenance and quality tracking system, BeFAQT. Thank you.
Thank you, Dave. Now I'm going to share the screen. All right. Okay, and so today we are going to talk about the blockchain-enabled fish provenance and quality tracking. Peter, can I hand it to you, over to you to start with the background?
Thanks very much, Ren. So as Dave mentioned, Sydney Fish Markets, largest market of its kind in the Southern Hemisphere. On any day, it can trade up to 100 different species of fish and other seafood. It moves about 1,000 boxes per hour, and that is to over 350 registered buyers. When UTS first came to talk about this project with Sydney Fish Market towards the end of 2017, the discussion was all about traceability of the project. The more we found out about Sydney Fish Market and the direction they were taking, the more we understood that they were very keen to move to an online system. But let's find out a little bit more about what happens on a normal day. So an auction starts at about 5:30 every morning. And that's on every weekday morning. An auction is held. The traders will come in around an hour beforehand. They'll have a look at the fish and the seafood. They'll get to know where and when the fish was caught. They'll get to know the sellers of the fish and the history of them. Then they'll also look at and do an assessment of the freshness of the fish. So what it looks like, how it smells, and eventually what's its shelf life, or try to get an understanding of its shelf life. The traders then bid at the Dutch auction according to these assessments. So the challenge we had when the research team came together with Food Agility and Sydney Fish Market was how to guarantee the origin and quality of unseen product. And so we held a number of workshops early on with groups such as Fisheries RDC, DPI, Worldwide Fund for Nature, and Newcastle Fishing Co-op to better understand the supply chain that we were working in. So the goal, having brought all this together, was to provide the online buyers the same experience as an on-site inspection. So an inspection where they could see the fish, where they could just about touch the fish. We needed to give them that experience. So over to you, Ren.
Yeah, thanks, Peter. The workshop is actually organized by Food Agility CRC. Food Agility CRC actually coordinates this very well. And based on that requirements, we provided a wide range of technologies, including we are going to develop a fisherman app to record the fish catch origin, the IoT sensing to get the supply chain tracking, the electronic eye, that image processing for visual to give the visual inspection experience, and the eNose gives the fish smell experience, and then the blockchain for the trusted data sharing. So all that technology, we are going to give a slightly detailed explanation later on. And our technology, as Peter just mentioned, our technology is trying to give the online buyers the same on-site experience. So even they are not on-site at the Sydney Fish Market, and from online, and they can have the same see, feel, and smell electronically. Let me hand over to Xu Wang, Dr. Xu Wang, who is in charge of the blockchain and blockchain app. All right, I'll stop sharing, and Xu, you can share your screen.
Okay, thanks, Ren. Can you see my screen?
Yeah.
Okay, cool. So I'm Xu Wang, the tech leader of the blockchain and the app part. And we first built among the trust for the supply chain parties and the consumers using this blockchain technology. And we built a consortium blockchain with 4 miners. The 4 miners can be maintained by the Sydney Fish Market and the other 3 co-ops. And all the blockchain data needed to be approved by these miners, and not a single party can tamper or forge the blockchain data. We also developed our own consensus protocol based on the besetting fault tolerance algorithm. And this consensus algorithm can achieve about 1,000 transactions per second. So it can fulfill the requirement of the fish supply chain. The figure on the right-hand side shows the status of our blockchain. You can see that there have been more than 1 million blocks and the transactions. And there are 4 active miners. The block time is on average about 6 seconds. We designed a new architecture to make the blockchain easy to use and compatible with other modules. On top of the blockchain, we developed the smart contracts to store and index fish data. And every time a new transaction comes, the smart contract will be updated by the 4 miners and then achieve the consistent status. We also developed the HTTP APIs to allow different modules and apps in our system, and also the Sydney Fish Market auction system to interact with our blockchain. And the figure here shows an example of our API result. You might notice there's a field of the TX hash. It gives the hash value of the transaction containing the fish tracking records. And after the blockchain, we developed a blockchain secured app for both fishers and buyers. With the Fisher app, fishers can take photos for fisher provenance when catching the fish. And meanwhile, the fish time, the location are automatically captured by the app. All this data will be cryptographically protected by the private key of the built-in blockchain module in the app, and then locked in the blockchain later. So the Fisher app can eliminate traditional paper-based logbooks and reduce human base. And the Fisher app also connects to our EIs and the IoT modules. On the buyer side, the BeFAQT app can show the fish catch province, and which is certified by the blockchain and presented as a map in our BeFAQT app. An example is given on the right-hand side. You can see a red rectangle, and this means that this box of fish was caught around the foster in the right rectangle. And buyers can get the province data by typing a smart tag like this, NFC smart tag. There's an NFC chip inside the near field communication technology. And the latest smartphones with the NFC modules can interact with this smart tag. So after this, I got a quick demo of our app. Our app is showing here. Is the SFM tracer. It supports both the fisher mode and the buyer mode. So the left-hand side shows the fisher mode, and there's a special entry here in the setting field in the fisher version. And the registered fishers can log in, use their credentials. And credentials, this is the main page of our Fishers app. And according to the functions listed here, the fishers can take blockchain secured photos for the catch province or for the EI module using the first function, taking photos. And this is an example. That can take photos. So this is the example taken in our Sydney Fish Market Lab. But in practice, the fishers can use this function on boat to take photos when fishing. One sec. So after the photo has been uploaded to the cloud and the blockchain, the fishers can select functions. Like here are 3 functions. The first is fish province, and then the rest 2 are used for the EI module. And at this step, the fishers can type this NFC chip to link the task with the NFC chip. So here it is, very easy to use. And then for the fishers can use the list, can check the task list to get the latest result of the image processing or the blockchain certification. And to the bottom, you might notice there's a boxing button that the fishers can link this task with the NFC chips and the Sydney Fish Market boxes. And other functions like to get the certificate provenance of a box of fish and manage the Sydney Fish Market boxes, and also manage the IoT devices to start or stop tracking. So here is the IoT management. And after all these functions, the fisher can log out in the profile page. Yeah. And then let's move to the buyers app. So the buyers can directly use this app, typically by tapping the NFC, the button, the NFC tracking. and then use their mobile phone to type the empty tag. And a result is presented. So this page shows the catch province, a video or the photos of the fishing. So this video and all the photos are certified by our blockchain, where the hash of the video and photos are locked in the blockchain. And this page gives more details, like where it is caught and what time it was caught. And also you'll notice there's a trace in blockchain. Using that button, our app can present the blockchain certifications. And this page shows the tracing of the box of fish from the fish being caught to Sydney Fish Market. The pins are the stops along the supply chain. And the last page lists all the stops in the text form. Yeah. Okay, so that's it. Thanks, Jen.
All right, thank you, Xu. And I'll go back to, can you stop sharing your screen?
Yes.
Stop, yeah. Okay. Yep. I'll continue with my sharing. Okay. Now, next one is Ying with the IoT. Ying, can you unmute yourself and start with the IoT introduction? Yeah.
Okay, thank you, Ren. Hello, everyone. My name is Ying. I am the tech lead of the IoT development in this project. So on top of the NFC solution that has been mentioned by my colleague, Dr. Xu Wen, we have also investigated a smart IoT solution. We designed this device in-house in UTS. And then develop the firmware as well. So this device can track time, location, and environmental parameters, for example, temperature, which is mostly used in this trial. So you can see it in the UI, in the slide as well. This device can run automatically, so no human interactions is needed during the supply chain tracking. And then this is powered by rechargeable battery for sustainability. And then the hardware and firmware are designed for low power consumption purposes. We use the latest cellular network technology, 5G ready one, which is category M and narrowband IoT. So this device can run without an extra or standalone infrastructure. So in our trial that's shown in this slide in here, we were using Telstra commercial and trial networks. So the collected data will be sent from this device to the cloud server, and then in real time, and then the cloud server will secure this data by blockchain. So as you can see in the picture, that's showing how we install the device on the Sydney Fish Market fishing box. So this is our 3D printed waterproof enclosure. So our device is going to be placed in here with the rechargeable battery, and then placed on the side of the Sydney Fish Market box. And then, so this enclosure is 3D printed and custom made for the size of the fishing box. In our trial, showing in this slides, our boat was approximately, our device on the boat was approximately 12 kilometers offshore, the furthest distance from the nearest space station in there. So we can still have quite good reception in there. So that's pretty much for the IoT side. Thank you.
All right, thanks, Ying. And Jian Professor Jian Zhang. I'm not sure, like he's traveling.
Yes,
okay. Yeah. I'll show the slide so you can start.
Yes, sure. Yes. Good afternoon, everyone. My name is Jian Zhang. I'm the image processing group leader from UTS, and we work on this project for the bigger component for the EIs. So that is mainly focused on the auto fish size measurement and also the fish freshness identification. Of course, we develop mobile EI platform. So for the auto fish size measurement, mainly we needed to detect the fish, and then we needed to the body segmentation, so we can measure the fish size. Of course, we also do the species classification, whether this is the snap or non-snap fish. And the big component for our image processing task is more for the fish friendliness identification. That is, we needed to work closely with the senior fish market. And first, we need to set up the freshness level index. The senior fish market team, they will give you the annotation for the freshness level, whether this is the top freshness, or that is second level, or that is third level. So they have the score called 0, that means top of freshness, and then the second level is 1, that is the moderate fresh, but the score is 2, means it's not good for food. So that is the freshness idea. We work with the senior fish market. They will build the ground truth, and then we will build our AI model to do this freshness assessment. The last goal is that we will build a mobile EI platform. So Wenping, next slide. So this one is, you can see the mobile EI platform. That is, we can reach to the freshness assessment up to 93 accuracy. That means we can work on the almost 93 accuracy. It's very important because each person, they have their own bias for the freshness assessment. Our 93 accuracy, that is in a broader way, which is we get rid of the bias, and we can use our AI models that are very fair to give people the freshness score. So in this one, you can see we just use a mobile phone as a camera. So mobile phone, you can use the mobile phone, take the picture, but the picture is not directly put on the fish. You have to put the fish within a box. You can see the box, that is the lighting box. The lighting box means we will unify the lighting conditions. So that means when this fish will be not impacted by the lighting condition in different places within the senior fish market. Based on this configuration, we can precisely to achieve the freshness assessment. So the lighting box is a portable lighting box. You can move from one place to other place. Yes, next slide, please. So after that, we also work on the size measurement and the species recognition. We also use just a mobile phone. You can take the picture. The first thing is we can take the picture, try to do the size measurement. You can look, you can see that we have the red rectangle. Red rectangle, that is the size. So with this size, we do the camera calibration. So in that case, all the fish within this size, we can give the size estimation. So this is, we can reach to almost like say 98 accuracy with the plus and minus 0.9 cm error, which is very high accuracy. And the second thing, we can use this mobile phone to do the species recognition in the same time. So just use the mobile phone, take picture, they will give you the size and also the species. When you use the lighting box, the previous size, you can do the freshness assessment. This is the thing. So you have this recognition things. So we can, for the measurement, we can reach to, like say that this is 90. This is quite a high accuracy. So next slide. So here is we give you 2 demos. One is the left-hand side, that demo is for the freshness assessment. So, and the right-hand side is for size estimation. You can see the freshness operation. Put the fish, then we add on the box cover. That box is with the lighting condition is constant lighting condition. Then with the mobile phone, they take the picture. We will take the 5 pictures. So they will give you the 5 scores. And after 5 scores, we will average 5 scores into 1 score. So it's a little bit small. I think it's Shu already gave you some assessment that they give demo. So that is the from left-hand side. The right-hand side, that is, right-hand side is, you can see they take the mobile phone, they take the picture, then they will quickly to give you the estimation how big the size and what is the species recognition. So it's a little bit small, sorry, because this is the mobile phone GUI, is not the PC GUI. So maybe it's not clearly to see that, but we will show you, definitely. This is well linked to the blockchain we call the Fish app. So the Fish app will give you embedded this information to show you the freshness level and to show you the many other traceability, the tracy information. So this is from image processing. Thank you, welcome for you come to this seminar. And because I'm not in Sydney, so if you have any questions, just raise to Renping and our project manager, and then transfer to me, I can answer to you. Thank you. Next is for eNotes. Thank you very much.
Yeah, thank you, Jian. And next one, and eNotes. Steven, do you want to share your screen?
Yeah, can I share my screen?
Yeah, sure. Yes, please do.
Yeah. Hi, everyone. I'm Steven Su. I'm the technical leader of electron nodes. So today I want to introduce the electron nodes development in from both hardware aspect and the software firmware aspect. First, let me introduce what's the eNodes. Actually, eNodes is developed electronic machine want to mimic the human olfactory system. So you can see this here is the eNodes here. Actually, I will show you my eNodes. It's actually here, the eNodes. And also here, the eNodes is here. Like when we do the experiment, we put the fish in the box and covered with ice. That's our first protocol, testing protocol. And the air control system will suck the air into the eNodes. Inside of the eNodes, there's a mixing chamber. In the mixing chamber, we put the sensor array there. So the gas sensor can sense the smell of the fish. And then from AD conversion, change to digital signal, and then use Wi-Fi to transfer locally to a computer and to the further analysis. So for the hardware design, the most important thing is a sensor array design. So how to select the best sensor to sense the taste of the nose of the fish. So first, based on the chemical component of rotten fish, we select 8 sensors. Finally, we based on the lots of experiment reduced to 4. So you can see the right ones the most typical components of the from the fish. After the select the sensor array, and then we put it in mixing chamber. So the mixing chamber should be well designed. We can let the density of the gas is evenly distributed. And to improve the the reliability, we use twin sensors. So identical 2 sensors. So in that case, we have 4 sensors, but we have a 4 kind of sensor, 8 sensors. So reliability improves. And in the future, we use a simple chamber for each sensor to further improve the robustness. And also we have the user interface. I will show you if you have time. And so in the user interface, you can automatically implement the testing protocol. You can set for example, the testing time and the washing time of the machine. And here is the 2 typical protocol. So the first one, we use fish box, put the fish in there and put the ice on it, and then we do the experiment. But this kind of protocol have some problem, like because the ice is quite cold and will reduce the sensitivity of gas sensor. This is like a human olfactory system. When have in the cold weather, your nose will be not sensitive. And in the later stage, we use the high space bottle. We put the sample inside the bottle, and then we do the test. And for the algorithm and the software, basically the gas sensor is not that smooth, because we need to use derivative features. We need to smooth the sensor output. So normally they use filter, but we provided a new method called modeling based. We use kernel-based modeling. And another very important challenging is like because the collect e-nose sample is time sometimes 2 or 3 minutes, and then when new samples come, we want to save the time, and we develop a method. We calculate the likelihood of the new sample with the fresh sample, and also we calculate distance from the new sample with the fresh sample. And then we can just adjust the threshold. We can corresponding to the fish freshness index. So use the first protocol because the sensitivity of the e-nose was reduced, and also we need to correspond with expert notation. But because of the ground truth for e-nose, maybe it's chemical components. So, but even though we still can get 86% accuracy for index 0, for index 1 and index 2 is around 70%. And then we change we use the ice day as the label, and we also use the distance, calculate distance. We can see the first several days, they not increase the distance with the fresh fish, but after 5 days, they started to increase. If we can find the threshold, we can corresponding with the index 0 and the index 1. So this is in the in the
yeah, okay. Okay, Steven, maybe we can finish off now.
Okay.
All right. Yeah, let me.
Yeah, finish.
Let me get into that. Otherwise, we'll run out of time. So the final component is the BeFAQT online trading platform. So as Peter initially mentioned, the City Fish Market want to build an online trading platform. So here's the online trading platform here. And this trading platform is actually a normal trading platform. You can actually buy fish and putting into basket, and then your card is here. And if you log in, and you can actually buy that, even pay for that. Of course, it's just an experimental platform, not for buying yet. So the question now is, as Peter mentioned, okay, we got all these fish, this information, but this is the static information. It's just there, right? It's a kind of like static. And how can we like inspect the real fish that we are going to buy? And that's where this kind of like this one is behind the video, and we use the as you already heard, the IoT tracking to track that fish from the catch origin all the way to City Fish Market, and we got the temperature, location, and time, and then we got the electronic eye record in here and the blockchain secured in here, and to estimate evaluate the freshness. And also we have the e-nose record Steven just mentioned, and get the electronic eyes, that's the smells record as well. And summarizing all of that IoT, EI, and the e-nose, and we summarize that into a 5-star rating system. And of course, the catch provenance was captured by the Fisherman's app. That's the Xu presented at the beginning. And so we got all that record. So they trusted, and we put that, of course, in the blockchain, and so that these records are trusted. And so we have developed this technology, and this technology has been trialed with the fishermen on the boat. and track that, and you can see the tracking record already. And to do these experiments, and thousands of fish samples are collected, either in imaging, in eNose, or IoT track record, or the mobile record. And what we have achieved at the end of this project is that we not only achieved the giving the online user the on-site experience so that they can feel, they can see, and they can smell. But also, moreover, we actually have given them more than the on-site experience, in that we give the authentic provenance, that's a trusted provenance, and we have a complete tracking of the supply chain quality. And also we give the unbiased objective quality assessment as well through this IoT, EI, and eNose. And our technology are ready for the online auction. And actually, we can say, because this is a real-time tracking, we can allow the fisherman to say, start, let's say, online traders start bidding even while the fisherman is at the sea, right? So through this online trading platform, we can broaden the market reach. As mentioned, as evaluated by the Brian Scapper, chair of the New South Wales Seafood Council, BeFAQT has huge potential. Once successfully commercialized, this technology can be extended throughout the fishing industry in Australia and potentially exported to other countries, benefiting the entire fishing industry. And as Dave mentioned in the beginning, and our project is a winner of New South Wales Eye Award 2020 for Business and the Industry Solution of the Year. And here's a team, here's the entire team, and it consists of academics and PhD students as well. So that's the end of our presentation. Welcome Q&A. Back over to you, Dave.
Thanks, Ren. Peter, Stephen, Yin, Shan, and Xu for your presentation. I do have some questions. They were coming in quite thick and fast there, so let me retail a few of them onto you if I may. First of all, question around the fish imaging. So I'll start at the present and work back if I may. So taking those fish measurements from the imagery requires fish being laid out a certain way, presented in the correct position. How compliant do you find that those in the fish markets have been to date in presenting the fish to give you what you would have confidence in a dimension measurement? Do you feel they're having no problems complying with the imaging requirements?
That's a question to Jian, I think. Jian, are you there? Maybe in the absence of Jian, I can substitute a little bit. Currently, our system is, of course, a minimum viable product, and we have in terms of the imaging taken and in some cases, especially on the boat, if the lighting is dark, then there can be a problem. And also in terms of measuring the size, and if there's no reference, kind of like a grid, then measuring the size could be a problem, because further away or closer will have different size measurements. So that's why the imaging team actually, you can see in the bottom of the box, they put a square grid there, and so that's as a reference. So that's but in the future, and for the lighting condition, especially in the cinefish market, and we have discussed with cinefish market, so we are planning to say in the future might be having that box on top of a conveyor belt, a short conveyor belt, so that the box is on top and the fish coming from the conveyor belt, and then under the box, there will be perfect lighting conditions. So that's why later on, the imaging team built that lighting, we call it lighting box, it's essentially to counter the imperfect lighting conditions.
Thank you, Ren. I have an eNose question then, just to give forewarning. So when it comes to the eNose, does it need to be calibrated for each and every fish species, or in the imaging case through a different eye appearance? So if we talk about eNose, so how detailed is the calibration process in terms of cross species?
Actually, before we attach this join in this project, we have did other like beef and other like fish. It's not necessarily with a snapper, but from my understanding, from chemical component point of view, because this really related with what sensor you select. So from our selection, I think like not the difference between species is not that a different fish is not that important influence if you use our method, current method. But if you want to tell the difference of different species, maybe we need to use different sensor. That will be hard to say at this stage. But from my understanding, if just for freshness detection, I think the fish the different fish, the result shouldn't be too different. But we didn't. We mainly focus on snapper at this stage. Yep.
Yep. Thank you.
Can you?
So okay, so just a couple of questions about the phone app and the logging of the catch out at sea. What happens in a situation where there's no mobile reception? So how does it? Can you give us a bit of an idea of how the system works in terms of offline and online?
Okay, this is Jian Zhang. I just want to quickly, currently our system is developed based on the mobile phone. This is because we want to utilize the city fish market environment. So if we're talking about if there's no mobile phone signals, actually we don't need the mobile phone signal for the whole system. This is because of course we can change the systems, but for the database, of course, we need a database transferred to the cloud. But for the front of the image processing, we can do the stand-alone, for this part. Whether I should answer questions. Thank you.
Thank you, John.
I would like to clarify the app dealing with the signal issues.
Yes.
So our app, yeah, thank you. So our app, So our app tries to upload all the videos and the images to the blockchain, immediately get this information. But in case of there's no signal coverage, our app also have the buffering scheme that they can buffer the videos and photos to the mobile phone and then upload to the blockchain and the cloud later on. When back to the back to the local co-ops, they can automatically upload to the blockchain. And actually, in our trial, the signal coverage is pretty good. We went offshore about 10 kilometers away and still have good connection. So not a very big deal in our case.
Thank you, Chief. Just because I know you spent some time, or the team spent time at sea, trialing and getting a basic feel for the usability of the system. What did you find was the response of the fishermen themselves, the fishers? Did they consider it labour intensive initially? Were they happy to just persevere, knowing it was going somewhere better, or did they really jump in on it, thinking, "Oh, this is not bad, really easy to use"? What was their first response?
Yes, I think like we did actually have a lot of discussion with the fishermen. Of course, their main concern is first question they ask is to say like, okay, whether this can earn us more money, right? So that's it. Of course, if you have a technology, fantastic technology, but it doesn't help them to get more money, then of course it's to them it's not use. Of course, for this one, what we're thinking is with this all this real-time tracking record, it can achieve higher bidding price. So that's what we hope for. And in terms of like the operation, they do actually mention to say, oh, all right, a box fish like maybe 20 or some small fish 50, and like one by one we do the catching, like maybe actually troublesome. So we later decided what we could is to say like, okay, a box fish and pick a sample and put on top of the box, snap a photo, and here's the box. So that's a probably sampling rather than every fish. So that's probably the solution. Yeah.
Thanks, Ren. And in fact, you mentioned pricing and the flow-on effects in terms of, I guess, revenue. And that was one of the questions I got asked a couple of times from the audience. How do you see the revenue model working for this? I mean, who would pay for this, and how would they realise that return on that investment?
Yeah, that's a very good question. That's actually the question in the Food Agility CRC workshop at the beginning. Before the beginning of this project, we have discussed that, and what we envisage at that time, and also we still keep that thinking that way, is that by providing this kind of like a real-time information of the catch provenance and also the supply tracking, and then the produce that the customer actually gets, right? They can actually see, so that can present it to the customer to say, all right, this is a high-end product, and you have seen right from where it's caught, and rather than kind of you don't know where it's come from. And so in that case, essentially we promoting, say, like Australian local catch produce, and by local catch produce, and of course we can achieve higher price, hopefully, for the fishermen. And also because this, as I mentioned in the last few slides, in some cases, the fishermen could even auction their produce while they are at the sea, and they don't have to come back to Sydney Fish Market. For example, if they caught the fish in Forster, and then the buyer is actually in Coffs Harbour, for example, rather than coming to Sydney Fish Market, then go back to Coffs Harbour, they can get that bidding information and directly go to Coffs Harbour to the customer. And so that's, in that case, it's save a lot of like this logistics as well. And of course, the brand name, right? If a fisherman always got this trusted information online, and he eventually can build up his brand name and then achieve higher price. So that's what we thought would be the business model for the fisherman or fishing company.
Thank you, Ren. And I guess a question for the team: we often are tempted to focus just on the strengths of these with a solutions sort of lens on it. When you look at the end-to-end system and the combination of imaging and capture, the blockchain, the IoT tracking of the fish, which is effectively tracking of the boxes, the image-based sizing and freshness and the eNose, and then of course the blockchain itself. Do you have a sense of any potential fragilities in the system? Because at the end of the day, when you put up a system, someone will want to game it. Have you got a sense of what you think would need to be key focal areas in relation to dealing with potential fragilities as this moves into an operational system?
Very good question. That's actually a question we are currently discussing with Food Agility, with our food managers in Food Agility, and with the Sydney Fish Market as well. The reason we have this wide range of technology for this project is 2 years ago, during that workshop, we listed all this technology. They could all contribute, but at that time, we are not quite sure which one can contribute how much proportion to this freshness, to this provenance and quality, right? And now with the data, with the result of this project we already got, And now it become very clear to us to say like, okay, which technology, how much they can contribute. So we are taking this result to Food Agility CRC, to Sydney Fish Market, and currently in discussion with them and with us, and to say like, okay, for the next phase, how can we proceed, and which technology we are going to pick and into the commercialization phase, which technology maybe is a specialized and can be in the special laboratory, and which one can be actually deployed to the supply chain. So that's all the questions we are currently discussing. Yeah, very good question. Thanks.
No, thank you, Ren. Look, thank you again, team, for your presentation this afternoon or this morning, wherever you are. Thank you all, ladies and gentlemen, for being a part of our seminar. Feel free to reach out to the team directly if you have any follow-up questions. And don't forget, we'll be releasing the recorded version of this seminar in the next couple of days through our YouTube channel. And we'll, of course, email you and notify you of that release. Now, this is the last seminar for the year. We'll kick off our seminar series again mid-February next year. So I guess on behalf of the Food Agility team, I wish you all a safe and wholesome festive season. Enjoying seafood, of course, if and where you can. Stay safe, stay calm, and keep positive about staying negative. And I wish you the best for a festive season. Thank you.
Thank you.
Thank you.